Calculus is used in business, finance, and just about every scientific field. It's useful because it describes change, and one thing that we see a lot of in this world is change. In this video, we'll make sense of the derivative in the context of an everyday problem. Let f of x be the elevation in feet of the Mississippi River x miles from its source. What are the units of f prime of x? And b, what can you say about the sign of f prime of x? To answer these questions, we just need to look at a graph. What are the units on the x-axis and what are the units on the y-axis? In order to know the units on the x and the y-axis, let's reread the problem. Let f of x be the elevation in feet of the Mississippi River x miles from its source. Our job is to place the units of feet on the correct axes and miles on the correct axes. So f of x will be in feet, and f of x is y. So I will write along the y-axis feet to remind myself the units are feet for y. And along the x-axis, it says that the miles are x. So I'll write miles along the x-axis. But to know the units for f prime of x, we have to recall that f prime of x is slope, and slope is simply rise over run. And rise refers to the change in y, where run refers to the change of x. Now the units of y are feet, and the units of x are miles, and so we're starting to see that f prime of x units are simply feet per miles. Now to analyze the sign of f prime of x, we will think about it as a graph. If it starts at its source and it continues down to sea level, the entire trip, the Mississippi River would be declining. The Mississippi River pours into the Gulf of Mexico where the elevation is 0. What can we say about the sign of f prime of x? Well, let's have a look at a tangent line that is sketched to the curve. The slope of the tangent line is negative. So to make a conclusion, we'll say that the sign value f prime of x is less than 0, which is another way of saying it is negative. Looking at a new problem, the temperature, big T, in degrees Fahrenheit of a cold yam placed in a hot oven is given by big T equals f of little t, where little t is the time in minutes since the yam was put in the oven. So we want to analyze the units of big T and little t. Little t is the x-axis. So we'll put that on the horizontal axis, that is, and big T is along the y-axis. So we'll put that on the vertical axis. And I'm writing in the units. Degrees for big T and little t is minutes. What are the units of f prime of t? Well, that would be degrees per minute. Next, let's try and form a sentence that would give the practical meaning of f prime of 20 equals 2. So let's include the units on each of those numbers. 20 would be in minutes, and 2 is the rate, so it's degrees per minute. So to make a sentence of this, we might say, at 20 minutes, at exactly 20 minutes, the temperature is changing at a rate of 2 degrees per minute. Now, let's sketch a possible graph of f of t. Let's create a starting point where the yam got put into the oven, and then the yam's temperature will increase over time as it adjusts to the oven. And what we have here is at exactly 20 minutes, we have a frozen point in time that we're talking about, and we create a tangent line at that point to talk about the slope of the curve at that point. And slope is rise over run. We have a slope of 2 degrees per minute. But let's take the interpretation of this problem one step further. We're given the same problem, but we have one more piece of information. F of 20 equals 150. So at 20 minutes, the temperature of the yam is 150 degrees. So we'll use the stated derivative, that is 2 degrees per minute, to estimate the value of f of 21. Create a slope triangle, rise over run. The run is 1, which also has units minutes, so we mark 21 minutes on the t-axis. The vertical change is 2. This corresponds to our slope, 2 over 1. We're now in a good position to approximate f of 21. The vertical change is 2, so add 2 to f of 20. That is, we take the value of 150 and add 2. This gives us 152 degrees, the approximate value for f of 21. So to interpret this, it means at exactly 21 minutes, we expect the temperature of the yam to be about 152 degrees. I hope that this helps in interpreting the derivative. Thanks for listening, and subscribe for more great math videos.